Hi, my name is Dr. Ain. In this video, I will share with you about electrochemical cell and cell reaction. At the end of this video, we will be able to differentiate galvanic cell and electrolytic cell, draw and label galvanic cell and electrolytic cell, and then write half an overall reaction equation of galvanic cell, and then write cell notation to describe the galvanic cell, and number 5 to describe the basic components of galvanic cell. There are two types of electrochemical cell. We have a galvanic cell, and also we can call it as a voltaic, and electrolytic cell. Galvanic cell derive its energy from spontaneous redox reaction, while electrolytic cell involve non-spontaneous reaction and thus require an external electron source like a DC battery or AC power source. So both galvanic and electrolytic cell will consist of two electrodes, an anode and a cathode, which can be made of the same or different metal, and an electrolyte in which the electrodes are immersed. The slide shows the galvanic cell. So remember, in galvanic cell derive its energy from spontaneous redox reaction. So in spontaneous redox reaction always have a positive voltage. And electrical energy released during the chemical reaction can be work to do work. Like I mentioned earlier, a galvanic cell consists of two compartments called half cell. The half cell where the oxidation occurs is called the anode. The other half cell where the reduction occurs is called the cathode. So the electron in galvanic cell flow from the negative electrode to a positive electrode. That means from anode to cathode. So as summaries here, for the galvanic cell, spontaneous reaction occurs. It does not require the external voltage source and also changes chemical energy into electrical energy, and the anode is a negative and cathode is positive. Okay, some tips to remember: red cat and anodes. So for red cat is reduction cathode. That means the reduction process happen at cathode. And anodes is anode oxidation. That means oxidation happened at anode. Okay, now we move to the electrolytic cell. An electrolytic cell is an electrochemical cell that use electrical energy to drive a non-spontaneous redox reaction. So an electrolytic cell has three component parts: an electrolyte and two electrode. Two electrode here, a cathode and an anode. The electrolyte is usually solution of water or other solvent in which ions are dissolved. So molten salts such as a sodium chloride are also an electrolyte. So when driven by the external voltage applied to the electrode, the ion in the electrolyte are attracted to the electrode with the opposite charge. But Only with an external electrical potential of correct polarity and sufficient magnitude can an electrolytic cell decompose a normally stable or inert chemical compound in the solution. So the electrical energy provided can produce a chemical reaction which would not occur spontaneously otherwise. So, a summary here for the electrolytic cell. So, in electrolytic cell changes electrical energy into the chemical reactions. So, anode is a positive, cathode is a negative electrode. So, non-spontaneous reaction occurs. So, they need require the external voltage source. So, now we move to the cell diagram, or we call it as a cell notation. Cell notation is a shorthand notation to represent the redox reaction of an electrical cell. So from the cell notation, the anode where the oxidation occurs is placed on the left side of the double line. Okay, so from the cell notation, the cathode where reduction occur is placed on the right side of the double line. Okay. So from the cell notation that I mentioned earlier, at the left side is oxidation. And the cathode where the reduction occur is placed on the right side of the double line. A double vertical line, okay, is used to separate the anode half reaction from the cathode half reactions. So these represent the sub-bridge. A single vertical line is used to separate different states of matter on the same side. And a comma is used to separate like state of matter on the same side. So how to remember the easy way to write the cell notation? So cell notation is easy as ABC. A for anode, B for bridge, and C for cathode. Okay. Now, from the cell notation showed in the slide, try to draw a galvanic cell and write half equation at anode and cathode, and then write the net equation. So how to draw the galvanic cell? So to guide you to draw a galvanic cell, first you need to draw two containers containing two electrodes. Next, the electron in the galvanic cell flows from the negative electrode to a positive electrode, meaning that from anode to cathode. So the half cell where the oxidation, loss an electron, occur is called anode. And then the other half cell where the reduction, meaning gain an electron, occur is called the cathode. And then label the electrolyte. Now you label the electrode after you labeled an electrolyte. So don't forget to add a sub-bridge. A sub-bridge is required to maintain the electrical neutrality and allow the reaction to continue. Okay. Now, from the cell notation showed in the slide earlier, now you are able to draw a galvanic cell. So here, zinc solid as an anode and zinc 2 plus 1 molar concentration as electrolyte in half cell for the oxidation at anode. At the other half cell, copper Cu solid is used as a cathode electrode and copper 2 plus 1 molar as electrolyte. So for the carbonate cell to work, the solution in two half cell must remain electrically neutral. So therefore, a sub-bridge containing, for example, KCl is added to keep the solution neutral by adding Cl minus and anion into the anode solution and K plus a cation into the cathode solution. So as oxidation and reduction proceed, ions from the sub-bridge migrate to prevent charge build-up in the cell compartment. You can see the more clearer about the movement of electron and ions from this image. And also, you can see the equation for the reaction at anode and cathode. At anode, zinc is lost an electron to produce zinc 2 plus. So zinc is oxidized. At cathode, copper 2 plus from the electrolyte will gain an electron and produce copper solid. So copper 2 plus is reduced. So this is how you write a half equation for the oxidation process and also for the reduction process. So, and for the net reaction, net reaction, the combination between the oxidation process and reduction process, that means for the redox reaction, we combine both reaction and cancel an electron at both sides, and then we combine it together. So the net reaction for redox reaction is zinc solid plus copper 2 plus aqueous, here 1 molar, to produce zinc 2 plus aqueous from the electrolyte and copper solid. Okay. So thank you for watching this video. I hope now you know the difference between the galvanic cell and electrolytic cell. Then you can draw a galvanic cell and then write the half equation for the oxidation, for the reduction at anode and at cathode. And then you know how to write the net reaction between for the overall cell, that means the combination between the anode, the reaction at anode and the reaction at cathode. So don't forget to do any exercises related to this topic. Bye. See you next video. Assalamualaikum.